Hi there, so today we're learning about sound attenuation and sound occlusion in Unreal Engine 5. Let's go. So we're inside UE5 in a third-person template project, and let's learn what is sound attenuation first. Sound attenuation is the way we hear the sound depending on the location of the sound emitter compared to the location of the sound receiver. So in our case, the sound emitter will be those two assets over there, one of a rock breaking and another of the water flowing. So let's first hear how does this sound sounds without any attenuation. So as you can hear, wherever we are on the level, the sound do not change a bit. So the location of the camera or the player does not impact the sound. Let's now create a sound attenuation asset just to hear what the sounds will sound like if we add some sound attenuation. So we are just going to keep all the default value except for this one. Let's put it at 1500. And let's add this sound attenuation to our sound asset by selecting the sound asset and then going on the parameter on the right, going on to the attenuation settings and by choosing the sound attenuation that we have just created. So as you can see, the outer circle over there, it's the parameter that we have set there. But we are going to go more in depth into all those parameters later on. So let's start playing. So here we are out of the outer circle. So as you can hear, there is no sound. As soon as we enter the outer circle, the sound starts playing, but it's very quiet. And as soon as we get closer to the sound, it's getting louder. And where we are very close, it's full volume. And as you can hear, the way we hear the sound really depends on the camera location. So let's go back to our attenuation assets so that we can go on through all the parameters. The first ones are those two over there, the inner radius and the fall of distance. So the inner radius is the smaller circle there. The radius control the radius of this inner circle, and the fall of distance control the radius of the large circle, the outer one. So how those circles work? Well, let's say that this star there is the camera and this shape there is the sound emitter. So when the camera is outside of the outer radius, the sound is not playing. When the camera enters the outer radius, the sound starts playing, but very quiet. As we get closer to the inner radius, the sound is getting louder until we cross the inner radius, and there the volume is at maximum volume. And wherever we are inside this volume, the volume is always the same. When we step out of the inner radius, the sound starts to fade again until we reach the outer radius, where the sound is not playing anymore. So that's how those two parameters works. And if we, for example, modify this one to 800, you can see that it's getting smaller, the larger one, and this one controls the smaller one. Let's put them back where they were. So for the two parameters at the top, the shape just control the shape of the two circles. I mean, it's not always circles. If we take a box, for example, it will be 2 boxes. Let's go back to sphere. And the last one, it's control how the sound will fade between the inner radius and the outer one. Let's go back there. For example, this one is the linear one, so the sounds fade linearly depending on the distance. There is also the logarithmic one, so as you can see, the drop is a little bit more extreme. So at short distance there are more variation, and as the distance increase, the sound's variation will decrease. There's also the inverse, so it's pretty much the same as the logarithmic one, except the drop-off is even more extreme. And there is also the log reverse. So for this one, the value of the volume is staying around the same, except when we reach a specific distance where there is a straight drop-off. And there are more functions. The natural one is a mix between the logarithmic and the reverse one. And you can also choose a custom curve, and you will build your curve manually by IDing your key one by one. Now let's go over the spatialization settings. So by default, spatialization is enabled. If we go back into the game, spatialization is the way we hear the sound more on the left side or the right side, depending on the camera location. So by default, this works fine. You can disable it totally if you don't want this effect at all. So there, wherever the camera is placed, the sound will sound the same. It will make the sound a little bit flat. And in this part, you can choose between panning and binaural. So by default, it will not change much, because the binaural one use plugins that you can set up when you go into your project settings. And let's search for spatialization. There, for each platform you can choose plugins, but it's more of an advanced usage, but you can do it if you need so. You can also choose a radius where the sound will not be specialized. For example, if we take 500, if the camera is within the 500 radius, there will be no spatialization. So this can be useful. For example, if we disable that and we go back, so there the sound is always specialized. And if we switch between the two panning, you can hear that there is a kind of a jump. So using this non-spatialization radius can be useful to avoid this jump. So let's go on to the air absorption parameters. So by default this is disabled. If we enable it, it will simulate the real air absorption effect that we have in the real world. So it consists in having the lower frequency sounds having a longer decay than the higher frequency sound. So overall your sound will sound a little bit lower frequency overall. For example, if we go into the game, maybe you can hear that the high frequency sound of the impact was disappearing way faster, but it's very subtle effect. If you want, you can tweak the value if you need so, but this one is for very specialized usage. You can tweak the distance at which the effect is applied. You can also choose the curve of how the effect will be applied, and also the low and high pass if you want to tweak the different frequency at which the effect is applied. Let's continue. So let's go over the attenuation focus. The attenuation focus is to modify the sound depending on if the sound is in focus or not. So what does in focus mean? Well, for example, if the sound is here on the circle, there it will be considered in focus, and here it will be out of focus. Of course, it depends on the angle value that we choose for that. The first one, the focus azimuth, it is the angle where all the sounds within this angle are considered in focus. And the second one, the non-focus azimuth, it is where all sounds outside of this angle are considered outside of focus. So if we take a small schema, there it is the camera, and in red it's the sound emitter. The dark triangle is the azimuth angle, so here the sound is considered in focus, and the gray one is the non-azimuth angle. So if the sounds were to be placed here, it will be outside of focus. There it will be in the transition area, so the volume will be interpolated between the non-focus and focus area, and there it's in focus again. And let's use the water flow sound for this one. So here the sound is in focus, so no attenuation is applied. And if the sound is out of focus, it is being attenuated. And we can also tweak the interpolation speed between the two states using this parameter. So if we increase the speed, with that, the transition between the focus and non-focused state is faster, and you can also make it slower by using a smaller interpolation speed. So there it takes quite some time to interpolate. Yeah, it's very long. And in our case, when the sound is in an angle larger than 30 but smaller than 90, well, it is in the transition zone, so the volume would be interpolated between the two. For the attenuation of the reverb, well, in our case we do not have any reverb applied to the sound, but it works the same way as the attenuation volume, where the reverb will be attenuated depending on the distance between the camera and the sound. So now let's go on to the attenuation occlusion. So by default this is disabled, but what it is that an attenuation will be applied to sound which are occluded. So occluded, it means that the sound is not visible, depending on the trace channel, of course. So the first parameter, the trace channel, it is used because behind the scene, to know if a sound is occluded or not, the engine will do some line traces between the camera and the sound, and for that it needs to use trace channel. So this is where you set it. You can choose between all the trace channel. You can even create your own if you want. The next parameter is the low pass frequency. So this will allow some sound below a specific frequency to be heard even if they are occluded. So usually if a sound is occluded, if you keep this default value, the higher frequency sound will be occluded and you will just hear the lower frequency sound. We'll see that a little bit later. The occlusion volume attenuation is the attenuation which is applied to the sound that are occluded. By default it is 1, so it will do nothing. Occluded sound will sound the same as non-occluded sound. The interpolation time is the speed of the transition between occluded states and non-occluded states. It's kind of the same as the interpolation for the focus. Next, use complex collision for occlusion. So you set this one if you want to use complex collision for the traces. What are complex collision? For example, if we go on the static mesh, and if we show first the simple collision, you can see that it is a shape that is around the mesh, but it's not very accurate. So this here it's fine, but sometimes it's not the best if you want accuracy on your traces. And if we show the complex collision, you can see that the collisions are the same as the shape of the mesh, so it's very accurate. It has more impact on the performance, but it's more accurate, so it's a trade-off. So you can check this one if you want. And finally, the plugins. If you have any plugins coming from assets or marketplace assets or anything like that. So let's test the occlusion. We're going to use this cube over there to have something between the sound and the camera. Let's put it like that. And let's say that we want to attenuate by 0.1, and let's keep all the default for the rest. So if we start the game, there you can see that here the sound is occluded, so we can hear only the lower frequency from the water, and the sound is very low. And as soon as it's not being occluded anymore, the sound is playing like normal. So that's how it works. So you can see that, oops, I thought, there we go. Does it simulate? Oh yeah, this one is simulating physics. Let's uncheck that. So yeah, that's how it works. And you can see that the transition is a little bit fast. So let's increase and say 1 maybe. So yeah, it's a little bit better like that. So that's what sound occlusion is. The next parameter, the attenuation priority, it's pretty much the same as the attenuation for the reverb or the volume. It will just apply the attenuation depending on the distance. So if you enable it, you can choose your function again or create a custom one. You can choose what will be the attenuation applied when you are at the minimum distance and at the maximum distance, and then there will be an interpolation between the two if you are in between the two distances, and there you can choose the minimum distance and the maximum distance. The Attenuation Submix is a little bit more advanced settings. It can be enabled if you want to apply attenuation depending on the submix that you send your sound to. So like every other parameter, you can choose how the attenuation will be applied depending on the distance. And the last one is if you want to enable the source data override. So I never really used it, but I guess it is if you have any sound plugin that modify the source data override, you can apply them there, but I don't really know much about it. So we've seen all the parameters of the attenuation assets. Now what we can do is we can just see how does attenuation is used usually in a real project. So usually you will create something like an actor. We'll then add an audio component to this actor, and there you will choose the sound. We're going to choose the water flow, and there you will apply your attenuation settings. And let's place our actor. Yep. And if we start the game, it's the same as before, but this time it's an actor using an audio component. And it's usually the kind of setup that we use if we have any actor that must emit a sound. That's it for this tutorial. If you liked it, you can thumbs up, subscribe and share. If you didn't, you can put in the comment why. And that's it for me. So see you another time. Bye.